Okay, here are the kits that you're going to receive from Taiwan. First of all, you will get the package like this, and this is the multimeter. Okay, and be sure that you put the battery. We need a 9-volt battery. Okay, so if you open it or use the with the screwdriver, you will see. Okay, there's a. It's an empty one, and you need to buy a 9-volt. Okay, any brand will be okay, but make sure that it's a 9-volt battery, and you just basically connect it firmly and put it back, and then use a screwdriver to make it complete. And then with this multimeter, you can measure several things. So first of all, you need to connect the two cable, and see that there are on the right hand side, you see the milliamp, volt, ohm, and a diode symbol. So that means that you can use this to measure small current, like in the milliamp range, and voltage, and also resistance, and also check the connectivity. Okay, so just connect that, and the brake cable, just for the common one, or you can throw that as a ground. And the left hand side, you see a 10 amp plug. Here, when you need to measure a high current level in the current level, then you have to switch that this red cable to this side. Okay, so but in this first measurement, you probably just keep this way. It's fine. And when you need to measure the voltage, you just switch that to the voltage side. And actually, you will see two voltage symbol here. The left-hand side, you will get the DC voltage, and if you switch it to this side, you will measure the AC one. And if you want to measure the resistance, then you just switch to the yellow region, and according to the level of the resistance. And you also need to measure the current, which is this, and you will see the different level of that. And for the 10 amp level, you, just as I mentioned, you need to switch this red cable to left hand side. And of course, you need to turn off it when you don't want to use that. And finally, there's another one. Okay, this one. You see a sign like a wave. You can check on the connectivity. For example, you just short the right. Okay, so now we are going to measure the IV characteristic of this solar cell. So before we do that, we will first of all we'll measure the open circuit voltage and short circuit current, and then I will show you how to make a series or parallel connection, and later on we'll see if there's a shades on one of the cell, which parameter will be degraded. Okay, so to do this, you will need the multimeter, of course the solar cell, and I use a lamp to emulate the sunlight. Of course, you can do it outdoor, but the sun source is not. I mean, during the depends on the weather. The sun light may not be quite that stable, so we would just use this lamp to emulate the sunlight. Okay, so first of all, of course, at the beginning, the meter will be in the off state, and you would need these two cables. One connect to the common node, and the other one to the voltage milliamp measurement node. And first of all, I'm going to measure the voltage. And for this cell, voltage is under 2 volt, so you can just simply choose the 2 volt slot, and then use the 2 cable. So connect the red one to the yellow, and the black one to the brown. You can see the voltage is 1.78. Okay, so it's under 2 volt. And you can check out the other one. Okay, it's about the same, but of course, different solar cells have different value, depends on the tolerance. Okay, now let's switch to the current. And the current, of course, depends on the level. I'm not sure, so I should just choose 20 milliamp first. Okay, so you just simply connect that again. Okay, so it's 1.3 milliamp. So you can turn to the 2 milliamp or just keep it this way, because later I will measure the parallel connection, so the current may be greater than 2 milliamp. Okay, let's check out the other one. Yeah, it's about the same. Okay, so let's connect 2 of them in series. So to make them in series, we're going to use this breadboard for easier connection. Of course, you can just simply wire them together, but in this case, I think it's easier to do it on this board. And before I start the connection, let me show you what's inside the board. Okay, this is a bigger breadboard, and if you tear this the back side out, you'll see some wire connected together. That means so let me show you this. So this, for example, there are 5 holes. Those holes are actually connected together. So if you want to do a serial connection, you may, for example, use this the slot 2, and the second one also in the same slot. That means they are connected in series. Okay, so since we are in the current mode, I will just measure the current first. Okay, so to make them have the same lighting condition, so I just put them all on the top. Okay, so it's about 1.2 milliamp. Okay. The reason you see the negative sides, I put them in different directions. So let me switch that to the correct one. Okay. Okay, so it's about 1.2 milliamp. Okay, under series connection, if there is a shade, so let me assume that there's something covered on top of one of the cell. The overall current will be degraded. So you see that the weaker one means that the one that covered with something, and that will limit the overall current of the cell. Okay, let's switch back to the voltage mode. And let me remove this first. Okay, so let's measure the voltage. You see there's 1 point something, but actually this is not right, because when you make the serial connection, the voltage will be the sum of the two cells. So that means it will be higher than 2 volt. So we have to switch to the 20 volt unit. Okay, so let me do the measurement again. You see that the voltage is about twice of the original one. Okay, and then let me plug it with some stuff there. You see the voltage doesn't affect much, but the current will be dragged down significantly. So when it happens, or when you know that there are shades will be on top of your cell, it's preferable not to use the serial connection. Okay, let's try the parallel one. So we know that the serial connection will add up the voltage together, but current will be remain the same. Okay, so for the parallel one, I will just put the red wire, the yellow wire on the same hole. So that means they are connected together. And the brown one on the same row. And I would need a wire, extra wire, for the measurement. Okay, so this.
板子被遮到。
这个。
对。
Okay, so let's start the voltage measurement first. Okay, so it's about 1.8 volt. So it's the same as the single one, because for the parallel connection, both voltage will be the same. How about current? Okay, maybe before I switch into that one, I create a shading there. You see the voltage is not significantly influenced by this. How about the current? Okay, the current before shading is 2.4. Actually, it's about twice of the original one, because in parallel connection, the current gets added up together. If there is a shade, you see the current will be reduced. However, the voltage doesn't influence a lot. So when there is a shading, it is preferred to connect both cells in parallel. Okay, so this is about the series or in the parallel connection of both cells. Now we are ready to make the IV curve measurement. To do the IV curve measurement, we need a load, which is in this case I'm going to use the. Okay, to do the IV curve measurement, we need a variable load, which is in this case I use a 10K ohm variable resistor. For a variable resistor means that you see that there are 3 pins there. So first of all, let's switch to the ohm section, and I will use 20K because since this is a 10K ohm resistor. And then you measure the outer pins. Okay. You see that it's about 10K ohm. And of course you can turn to different direction, but it doesn't affect the overall resistance. But if you measure the center from the outer pin, you see that this is 4.1, and the other side is 6.27. So that means the sum of these two, the resistance of these 2 pin and the resistance of these 2 pin, the sum of these two is about 10K ohm. So let me show you how to change that. So if you turn, you can see the value will be changed. So we are going to use that. Okay, so let me show you how to connect that to the circuit. So first of all, you will need to use one of the solar cell. So one pin, for example, in this case to 11, the other to 16, and then I'm going to do a serial connection. Okay, so I will connect one pin to the 16, and I will also need the center part. So for the center part, I'll get the wire here. Okay, so now we have this solar cell connect in series with the resistor, and then I can try to change the resistance of this side, and then you can measure the connection. But actually we need the solar panel connect in parallel with this resistor, so I will use this pin to connect to the other side of the solar cell. Okay, so now we close the loop. Then we can start to do the measurement. So we are going to again to measure the voltage and also the current. Remember that in the previous measurement we only measure the open circuit voltage and short circuit current. And in addition to these 2 conditions, we need to change the resistor to get those situations. So let me show you how to do that. So first of all, we are going to measure the voltage. So I will get another pin. Okay, so there's no room for that. So let me move it back. So I connect it there. Okay, so sorry, the pin should go there. So we can measure the positive voltage and also the negative voltage of this solar cell. Okay, so you see it's 1.745 volt. So if you change the resistor, okay, so that's, you see the voltage will be different. So you see smaller load, smaller resistance will end up with smaller voltage. So in this way you can change the load and get the different voltage measurement. But remember that when you have to fix the resistor. So when for example, I switch to this side and then I do the measurement. So in this case, it's about 1.2 volt, and then I need to measure the current simultaneously. But since we only have 1 meter, so let me break the loop. So I break it. So when you break the loop, you can insert the current meter. So I insert the current meter in between, so I can measure the current. Okay, so this is just one set of the measurement. So you will repeat this again. You will change the resistor and measure the current. Okay, and then switch back to the voltage section and connect this pin back to serial connection, and then measure the voltage again. So keep doing that and repeat all the data, and then if you plot the result, then you will see the IV curve just as the same as we told you in the previous section. Okay, so get ready to do that. Today we'll go outside to do the testing. So first of all, we need some wires to make the connection for a better measurement. So let's get started. So first of all, open the case, and you need 2 wires to do the connection. So use a screwdriver to remove. Okay, this is for the positive node. So it's better to use a red wire. And second is a negative pin, so it's better to use a black wire. So put both wires in the centers to stable it. So put the lid back to the case. Now we are ready to do the measurement. Okay, this is the solar panel we're going to do the measurement. And check out the spec here. The maximum output power is 10 watts. And the maximum output voltage at open circuit is 18.18 volt. And the current here is 0.55 amp. So later we will use the meter to do the measurement. Okay, so first of all, we need to decide the orientation and also the tilt angle. So if it's possible, you can download some app or get the real compass. So here I have the compass, and we can check out the orientation. And Taiwan is located at North Hemisphere, so the solar panel has to face to south. So here this direction is north and the other side is south. So if we have the panel, we have to put it this way. And then we need to have a protractor to decide the tilt angle. So here I have download Okay, here I have downloaded a protractor, so you can try to align with the panel, and then you can see what's the tilt angle. Okay, so this is 0 degree, and if you put that in 90 degree, actually there's less sun, so you will expect to measure the output with less power. Okay, so let's get started. Okay, so we try to put the panel face to the south part. So later we will change the tilt angle along this side. Okay, so let's have the 0 degree. Okay, you can see the output voltage is 19.15. This is open circuit voltage. So let's start to change the angle. The output voltage is reduced slightly, but if you check out the current, you may see the differences. Okay, so let's put it back. So change to the current meter. So now the current is around 60 milliamp. Okay, so if it's at the right angle, the current is reduced significantly. Okay. But actually, the most important thing is the output power. So in your lab, you have to change the tilt angle. For example, you can change that to like 25 degree, and then you measure the voltage and also the current, and record the number, and then multiply the voltage with current. You will get the output power. Therefore, you can find the best angle for your location. Typically, the best angle is the same as your latitude. If you need to charge your devices with the USB connector, then you can use the wire that I give to you. And instead of putting these two wires, you can connect the wire of the USB side to this panel, so that you can charge your devices. But be careful, since the power rating here is 10 watt and the output voltage at open circuit is 18 volt. So you have to make sure that your home appliances, all the things that you want to charge is within the safe range. Otherwise, you can purchase a small regulator circuit that you can connect to your panel, and then the output will be a stable 5 volt.